All right, we already did this. Figured out. Last lesson. Yeah? Good start. All right. Guys, we did this part too, but I think last time we did it from the other direction, right? We said f of x, what's going on with f prime of x? I don't think we did it this way. I can't remember. If we did it both ways, great. This should be review. So, no. If f prime is equal to 0, what does that mean is going on for f of x? Good. So here we're going to say critical point, sure. That's one of the things we could say. We could say critical point. Okay, so we actually can't say that. What we could say is possible relative max or min. Why can I not say relative max or min?
Because we don't know.
No, but good try. Yeah?
It could just be like y
No,
Know that.
because it doesn't have to be a critical point, and that's one of, or it doesn't have to be, sorry, a max or min, which is one of the things we're going to talk about today. Okay? There's another type of critical point, and then later we're going to learn another type of critical point. Okay? So we got to say possible. What it really means, though, for sure, is it's got a horizontal tangent. Right now, like, that's usually, for right now at least, we can say that it has a horizontal tangent. Okay? What about if it is greater than 0? What does that mean for the original? Increasing. What does it mean if the derivative is negative? Decreasing. See, you guys know this. Like, why do you guys pretend like when I'm not here you don't know anything?
You taught this when you were here.
You know, I go over it every class. It's pretty. This is going to be part of your life, like almost every lesson. Okay. When it changes from positive to negative, what is it? Why?
No, it's a 0.
Why is it a relative max? Because it was going up, increasing, and then it was going down, decreasing. That has to be a max. Why would it go from negative to positive? What? If I go from negative to positive, it's a relative minimum. Look at that. All right, now we're going to draw a graph. Actually, we're going to sketch it. So here's my f of x over here. Here's my possible f prime of x. So I need to figure out what it might look like. We can actually do it with a lot of accuracy. What points should I look at, do you think? Good. Critical points. I'm going to look at all three of those. If it's a maximum, what is the derivative doing?
It's going down.
Switching.
Going up and then it's going down.
So
From
how is
positive
it
to negative.
positive to negative? That's the key, okay? So at this point, which is 1, 2, 3, negative 4, we know that it has to go through it this way, right? It's got to go down, okay? At this point here, it's a minimum. What is it doing?
It's
From negative to positive.
Negative to positive. So at 1, it has to go from negative to positive. And at 1, 2, 3, 4, 5, that's where the other maximum is. It needs to, once again, go from positive to negative. At that point, I can at least sketch it. Okay, it's not going to be perfect, and we'll learn ways to make it even better later. But for now, we know that that's going to continue off. That one's going to continue off. And then it's got to basically connect the dots, or connect the zeros. Something like that. Make sense? I don't need it to be perfect. But do you get the idea?
Yeah.
So we can at least figure out roughly what it might look like. What? Yeah, exactly. That's a good point. So this one here is quartic, and this one here is cubic.
what it's called. Are you gonna teach us that or should we?
You should already know it. Quartic just means that it's degree 4, right? 4th degree. You also know that this one's negative. And guess what? This is a negative cubic as well. Right? Guys, if we really need help with this, I might give you an assignment.
Can you put it like an academy or something?
No, I'm just going to give you an assignment. I'm going to give you an assignment. It's great. It's fun. I usually do give it. I didn't this year, and I'm regretting it. Okay, stop making dumb noises. Seriously, do it again, you're going out.
What?
You're going for a walk. Straight to Valentine.
Can we go with you?
No. Picture below. Graph of f of x. Answer the questions about f prime. So we've already shown you f of x. Approximate the value of f prime of 4. So if I want to find the derivative at 4, and I'm approximating it, what did we say we did again previously?
We trace a line.
We do a secant line.
A secant line.
of the two closest points, which are going to be these two. This point here is at 5, 4. This one here is at, looks like 3, -1. So I just use those, right? 4 minus -1 over 5 minus 3, right? Basic way. This is just finding the slope of the secant line. So it's 5 over 2, right? Mahal, I'm out of you. I don't want to talk to you right now. So you picked.
Why do you choose those points? Because they're closer to each other.
What do you need, Mahal? What do you need?
Why do you choose those points if you said they were closer to each other, but the ones that
Okay, why did I choose those ones? Guys, what if I don't choose the points close? Let's say I chose this one and this one.
No, mister, but you have all these that are way closer.
With a tangent line.
No, pero
Guys, I don't have any that are closer. Are you kidding?
With a decreasing slope.
There's literally none of them that are closer.
closer to what?
Look. Let's zoom in.
Okay, closer to 4.
If I'm checking this point,
I know closer to 4. No,
there's nothing closer. Like you're gonna tell me that you can tell me exactly what that point is? No. Like it's 3.4, 5, 6. Like you have no idea. You have to use actual points that you know.
sorry.
I know. It happens a lot. Not always. I didn't say always. I said a lot. All right. At what value of x is f prime of x going to have a 0?
-3, 1. No.
-4, 1, and justify your answer because f of x has what? Yeah, which if we want to talk about all of them, we can say has
Critical points.
critical points.
Can I put it because they are critical points in above x?
On what open interval is f prime of x going to be less than 0, negative? Start with the justification. Why is that going to be the case? Because f of x, don't say it. If you say it, I will not give you marks. You have to specify. Because f of x is decreasing. Guys, I know that I kind of was mean to Gabriel just then, but it's because that is where I take more marks off for this unit than anything else.
What?
Okay? You
Nobody-
cannot use it. You must tell me which derivative or which original function. Okay? No. You need to say like
So
f of x, g of x, f prime of x, f double prime of x, whatever it is. Okay?
what did Gabriel say? Because
We'll get there. And where did it happen?
why did Gabriel say that you said it's not allowed? The
Just say
idea
it.
you said.
I said you can't say it. You have to tell me which function.
So
Be
because
specific.
it's decreasing, what you want to
No, you have to tell me which function is decreasing. Okay, otherwise it's not right. We need to know where it's negative. It's where it's decreasing. Tell me where that is. -4 to 1 and perfect. There we go. Now the next one. What's our justification if the derivative is positive?
It's increasing.
Yeah, but except that we just got it wrong. What is increasing?
The f of x.
F of x. Guys, like I said, I have to stress it. I know, but she didn't. I have to stress it because you got somebody will mess it up and then you'll be sad. And then I'll be sad for you. And then we might cry together. Okay, when is it increasing?
Negative.
Good. And?
1, 2, 5.
Negative.
Good. Yeah, negative infinity, -4, and then from 1 to 5. Okay. At what values does f prime of x go from being below the x-axis to above? So in other words, what is it doing? It's switching from negative to positive. So why would that happen first? Because f of x has what?
Critical points.
What critical? There you go, minimum. Be more specific when you can. So you're not wrong, but it's better if we say minimum. So because f of x has a relative minimum. And where does that happen? At x equals 1. Good. Okay, again, I'm not scrolling up, but the graph is in front of you guys, right? So you can easily look at where the minimum is, okay? If you need me to, I can scroll up and down, but sometimes I think that's more confusing because you're trying to copy what I'm writing, okay? At what value of x does the graph of f prime of x go from being above the x-axis to below the x-axis? So in other words, it switches from positive to negative. There we go. Because f of x, can't say it, has a relative max. Where does that happen? Good. List both if there's more than one. Feel good?
Yeah.
Great. Should we continue?
Sure.
Awesome. Who said wait? What do you need?
No.
You're good now? Okay. All right, now this time we've got the derivative, and we're going to answer the question about f of x. Guys, what do you notice about these two questions?
That they're like asking you for the thing that it's not on the graph.
Exactly. I'm rarely going to ask you about the graph that I show you, right? Almost never. So this one, I showed you f of x, I asked you about f prime. Here, I'm showing you f prime, I'm going to ask you about f. Okay? Ladies, stop eating candy in the class. No, you can eat it, just don't buy it. Or at least not when it's distracting. On what open intervals is the graph of f of x increasing? Start with the justification. Because f prime of x is what? Positive happens where?
From -3 to -2.
There we go. Right? Only happens right here. Okay? Only there. That's the only place it's positive. Next part is where is it decreasing? So be careful with this. Let's start with our reasoning because f prime is what?
It's less than -0.
Less than 0 or negative, yeah. And it's going to happen where? Be careful and think about this.
2 to 2 and from 2 to -4.
Good. Why can't I write it just from -2 to 4?
Because they're the graph is
There is a critical point at 2, and we're going to talk about what kind later because it's not one we've seen before. But yeah, basically it's at 0, which means that it is not increasing nor decreasing. Therefore, we can't include it as saying it's decreasing there. Okay? Because at that split second, it's not. At what value does it have a horizontal tangent and why? Well, let's start about the justification first. So f prime of x is what?
0.
Equals 0. When does that happen?
At 2.
-2 and 2. Right? It also happened at 2. Because at -2 it's equal to 0.
At -2.
Right? Like we're literally just reading them off the graph, right? Right here and right here. It's equal to 0. Right? That's why I said it's easy if we start with our justification, guys. Because the justification is what tells us what's going on in the graph we're looking at. So then we can look at it. Right? Otherwise, you can't really, like it's more difficult. Okay? When does it have a relative max? Well, let's start with the definition or the reasoning. f prime of x.
It's going from positive to negative.
Good. So we can say like switches positive to negative. When does that happen?
2 and at -2.
Just one.
What?
Just -2. And we're going to talk, I'm actually really happy you brought up the other one. Okay. See?
New critical points.
And when does f prime of x, okay, what is it doing if we're going for a relative min? It switches how?
From negative to positive.
Negative to positive. And where does that happen?
Nowhere.
Nowhere. Nowhere. Never actually happens. Doesn't happen, right?
No está sobre el x-axis.
Never happened.
Right, guys, look up here. Up here, it switched from negative to negative. So it went from decreasing to decreasing. It did something weird. It had a horizontal tangent, but it decreased. We'll talk more about it. We'll keep talking more about those, what they are. Okay?
Isn't that the one that goes like this?
Yeah. Yeah, it's called a point of inflection.
You should go just for
Okay, so what is the slope of the normal line to the graph of f of x at x equals 4? Not the normal line, like not the equation, I just want the slope. So what do I need first? So I need f prime of 4 because that will tell me like what the slope is, and then I can use that to go and find the normal. It is -2. So if we go look up here at -4, wait, was it -4?
It was 4.
That makes more sense. Yes, there we go. 4 and it was -2. So at 4, the y value is -2, so my derivative is -2. Which means that somebody already said it. What is my normal line slope?
Then I read reciprocal.
Exactly, negative reciprocal, so it becomes 1/2. Amazing.
And there's no justification for that.
So what?
Justification for that.
Yeah, I don't justify, like it would be, all you can really do is say that it's the negative reciprocal of the tangent slope. Which I don't think you can do it. It's okay. All right, guys, let's put it all together. What are we doing here? Here, each of the given functions, we want to determine where it's increasing, decreasing, relative extrema coordinates, and perform this on all of the domains, so negative infinity to infinity. What we're going to do, you guys, is something that you're going to do a lot of, and it's called a sign analysis. You've done this before in pre-calc, and I actually know you have, because every year the students are excited that I don't have to say allegedly for once. You did learn this. Huh? I don't know what the heck it's called. You probably have some weird name for it, but it's sign analysis. So, sure.
That is like
I
Let's go through it.
This interval is positive, this
it's
interval
a
is
number
negative.
line, and it's like negative.
But we're going to use it in terms of calculus now to interpret things. But yes. So, it's easy. F prime of x. Who's feeling like they know it?
What?
Me,
No.
Ariana knows it.
Okay, tell me.
Wait, actually,
Emilio, help her out.
15x to the 4.
What's the derivative?
15x to the 4.
15x 4.
Minus 15x squared.
And
Good.
then we can.
Guys, we're going to factor it to make our lives easier. So I can pull out a 15x squared, which would leave me with x squared minus 1. But what is x squared minus 1?
X
So I'm going to write it as x plus 1, x minus 1, because the factored form is always going to make this easier, because then it's easier to make my sign chart, right?
Yeah.
Good. All right. Because we know that, remember, the critical points here happen when? When the derivative is
0.
equal to 0. So in other words, that's going to happen, like this is,
A negative 1 of 1.
and there's another one.
And
So it's going to be x equals 0,
Yeah, that's 0.
and then negative 1 and 1. So those are our 3. Then we're going to go ahead and we're going to draw our little chart.
Ay, qué rico.
Look, see, you're so excited. You're literally, ay, qué rico. Look at you being all excited about that sign chart. Well, it hates you too. All right. So then you got to find something on the interval. Guys, always pick numbers that are easiest. Okay? So I would argue like probably 1/2, negative 1/2, 2 and negative 2. Okay? Now here's why we did it in the factored form. Let's start with negative 2. Anything squared is positive. Negative 2 plus 1, negative. Negative 2 minus 1, negative. Because I'm multiplying all these. That's why we do it in the factored form. You forget plugging it into your calculator. That's a whole lot of extra work. If you have it in factored form, it's positive times negative, negative times negative, positive.
We just check the end behavior.
So all in all, it's positive. Okay? Then I'm going to use negative 1/2. Anything squared is positive. Negative 1/2 plus 1, positive. Negative 1/2 minus 1, negative. Overall, it's negative, therefore it's decreasing. Put in a half.
Wait, can you pause it right there? I don't know if you keep it.
What do you need? Mariana, what do you need, dear?
What?
What do you need?
No, I needed to check to see if the way that I do it was working.
All right, so let's plug in a half. Anything squared is positive. 1/2 plus 1, positive. 1/2 minus 1, negative. It's negative, it's decreasing. Then let's plug in 2. Anything squared is positive. 2 plus 1, positive. 2 minus 1, positive.
Easier way to do it.
There's lots of ways to do it.
You check the coefficient is a degree. The behavior is up. And then if the first exponent is not even, so it crosses, and it's even, so it bounces.
I'm not going to teach it that way because a lot of people are not going to follow it.
Easy.
Can he follow it?
Yes, you can.
Sure.
For example, when it's like a close thing.
See? He's like, what? He's like, que cosa? Okay. All right, guys. Now this tells us a whole bunch of information, right? The reason I drew the arrows, it tells me where it's increasing, decreasing. It also tells me that if it went from increasing to decreasing, this is a max. Decreasing to increasing, that's a min. This is an unknown thing that went from negative to negative. Like I said, we'll talk about them, but basically you just need to know it's something that looks like this, and it's a point of inflection. We'll talk more about them when we do the second derivatives, okay? For now, you just need to know that it's decreasing, decreasing, and it looks kind of like that. All right. Then from there, it asked us to do the intervals and the points. So let's do intervals first. f of x is increasing where? All the places the arrow points up. So negative infinity to negative 1, and from 1 to infinity. Why? Because
Those arrows like that.
f prime of x is positive. Yeah, sure you can.
Like f of x is increasing and we just put an arrow.
I mean, yeah.
Hi, mister, but you also need to know if it's an open or closed thing to know
Bracket.
if the bracket or the.
No,
Ya.
nunca hacer
Ay, qué
brackets
rico,
porque es
no.
que
What is happening at those critical
tiene
points?
que haber un punto
It's
en el-
horizontal, therefore it's never included. Yeah.
porque tiene-
But I like that you thought about that. That's good. Look at you thinking about all the things. All the things. Good job. No, really, all right. I don't think you believe me, so it doesn't matter.
Una pieza
I
mañana.
don't think it
I
matters.
am going through withdrawal.
Of calculus?
O sea, que si te salió síndrome de
So it's decreasing from negative 1 to 0 and from 0 to 1. Why is it doing it? Because the derivative is negative. Stop cussing, man. Just because you cuss in another language doesn't mean you're not cussing.
Lisa, right? And we can also write it like this, like f of x is less than 0, and then you draw the weird E thing,
Sure.
and then you do the.
I'll come look at it after. All right, where's my max? It's at negative 1 and f of negative 1, which means that it's really negative 1 and...
What is everyone?
Guys, I'm literally just, I know that the maximum happens at x equals negative 1. Plug in negative 1 into the original equation. Negative 1 q, or to the power of 5 is negative 1. So negative 3 minus 5 times negative 1. So negative 3 plus 5 is 2. Somebody said it early. I like it. Somebody was with me. All right, now minimum.
Thank you, it was me.
It wasn't, but that's okay. F of 1 equals. So now I'm plugging in 1. So this time it's going to be 3 minus 5. So that's negative 2.
Pero, mister,
Oh, no.
plug in negative one in that equation and then
Into the original equation. Original equation.
how did you get 2 points?
What do you mean, where did I get 2 points? I didn't get 2 points.
You got negative one.
F of 1 is negative 2.
Wait, mister, these are opposite points in the graph of.
They are. Are you, what do you need, Ariana?
No, if you plug it in, mister, what did you do? Like, you get negative 1 and 2. Negative 1 and 2.
Because I plugged negative 1 into the original equation.
Yes, but that's going to give you one number and one number. Why did it give you 2 numbers?
It's a coordinate.
Where did you get that number? You plugged it in and it gave you negative 1.
No, I plugged in negative 1 and it gave me 2. It's just a coordinate.
So we can now plugging in and it gave you 2.
All right, last one. Lots of trig, because we love trig. We do. We do. Don't kid yourself, you do.
I love trig, mister.
Derivative of theta?
1.
Derivative of 2 sine theta? 2 cos theta. Then I'm going to solve it for 0. We're expert at algebra, so we're going to say that that's negative 1/2. Yeah. It gives you less chance to talk. So I moved over the 1, minus 1, and then I divided by 2. So cosine of theta is equal to negative 1/2.
4 pi over 3. No,
What else?
4 pi over 3. And then it also is.
11 pi over 6.
Mister, I'm so sorry.
There's another one. What's the other one?
11 pi over 6. 7 pi over 6.
No.
2 pi over 3.
Thank you. 2 pi over 3. Okay, so 2 pi over 3 and 4 pi over 3 are where we're going to have our zeros. That's our critical points.
Mariana, quítate.
No, wait, no, déjeme.
Ladies, I'm going to have to stop the video again and wait for you.
Mister, we're going to measure with the freaking thing.
It's not even hard. Don't worry about it.
No, no,
Guys,
no.
what's an easy one that's between these two?
0.
3 pi.
Pi. Just pi. What are you doing like all these decimals? Guys, use radians. You need to get used to them. What is bigger than 4 pi over 3 that is easy, that is not 2 pi, because I'm not including 2 pi?
5 pi over 2.
Están ordinarios, ok.
Yeah, but I'd probably use 3 pi over 2 because things are 0 and 1, right?
Yes, sir, but why is
Because it says you can't include it.
Ah.
And then down here I can't use 0, so let's use pi over 2. You use whatever's easier for you. But I think the cardinal directions or pi's over 4s, etc. are easier.
Yes, sir, and how are we supposed to plug those values there? Like I discussed.
El lente estaba carísimo.
It is not disgusting. Watch. Watch how easy it is. What is cosine of pi over 2? What's cosine of pi over 2? 0. 0 times 2 is 0. Plus 1 is positive. Let's do pi. What's cosine of pi?
0.
Negative 1. So times 2 is negative 2. Plus 1 is negative. It's decreasing. Let's do 3 pi over 2. Cosine of 3 pi over 2. 0.
0, yes.
Times 2 is 0. Plus 1 is positive. It's increasing. So, max, min.
Wait, mister.
I can't.
What did you just do?
I just plugged in, I used the unit circle there. Cosine of 3 pi over 2.
You don't have to do it 3 times to get the...
No, I just plug it into the equation.
Ah.
I just want to know if the derivative is positive or negative. This is the derivative. Plug it in. There's only one theta. All right. So, let's talk about where it's increasing. Now remember, we can't be less than 0. So this is going to be increasing from 0 to 2 pi. That's a really ugly 2. Let's fix it. 2 pi over 3. And from 4 pi over 3 to 2 pi. Why? Because f prime of x is positive. Where is f of x going to decrease? Only from 2 pi over 3 to 4 pi over 3. Because what is f prime of x doing?
Decrease.
Yeah, negative. Because the original is decreasing because the derivative is negative.
Because f prime of theta.
No. Oh, was it theta? Yeah, it would. Yeah, it would. Good call. It doesn't really make a difference, but yes, you're correct. We should technically put thetas in there. Good call, Emilio. Good call. All right, so now I got to figure out where my max and min are. Ariana, don't panic. But it's at 2 pi over 3 and f of 2 pi over 3.
Sir, this is very long.
No, it's not. Which is 2 pi over 3. Guys, it's only long because of how much you talk. If you watch me do this video without any students, I do this video in like 25 minutes.
These are because you are the teacher.
Because you studied
Yeah, but that's my point, is it's not very long. Because here's the thing, Camila, when you do it, you might ask one question, but everyone else waits while I answer your question. And then later, I didn't say that. I said Camila. Then later, Camilo asks a question that's completely unrelated, and you have to wait for that one too. So my point is, there's a whole bunch of like interruptions because you have to wait for everyone in the class, right? So that's why it takes longer. It's not a big deal. All right. When I plug in 2 pi over 3 into the original, which is up here, I'm going to get an ugly number. I'm going to get 2 pi over 3 plus, what is sine of 2 pi over 3? Square root of 3 over 2? So it would be 2 square root 3 over 2 or plus root 3.
Why does 2 cancel out?
So this whole thing is my y coordinate. It's a little ugly, but it's exact. Now let's do the minimum.
What happened to that mister?
All right, and then this is going to be f of 4 pi over 3. So that's obviously going to be 4 pi over 3, and then I'm going to plug in 4 pi over 3. I'm going to write it here so you can see it, guys. It was, the original function is theta plus 2 sine theta. So the first part is obviously still just 4 pi over 3, because that's what theta is. Plus, what is sine of 4 pi over 3? 2 times negative square root 3 over 2. So those cancel, and I will get the point 4 pi over 3, comma 4 pi over 3, minus root 3. And that would be it, where this whole thing here represents my y in exact form. Okay? I agree. That's what I've been trying to tell you.